Okay, so first of all, have you people gone through the mock paper?
Yes, ma'am.
So how do you find it? Are you able to solve the questions?
Yeah, we were able to solve the question, but there were some mistakes that I think will be improved.
Ma'am, can you go through it for it will be better for everyone, ma'am.
Yeah. Anyway, I think shortly you will receive the solution PDF in your portal. I have shared it with the ops team, so
Okay,
maybe
ma'am.
before night you may get it available on your portal as well. So
Okay.
today I will just go through the topics of this quiz one. So you have week 1 to week 3 for quiz one. Okay, so since we have sufficient number of topics in the first 3 weeks itself, for quiz one, week 4 is not included. Week 1 to week 3 is the portions for quiz one, and you would have seen that through the mock paper as well. Let me just discuss the mock paper sometime later in today's session. So right now, I'm just planning to go through some additional numericals for the same topics that are covered for quiz one. Is it fine?
Yes, ma'am. And one doubt, ma'am, regarding the problems, how will be that, ma'am? Like the circuits and all based on we may need for if suppose a polar and rectangular form means we may need calculator, right? The how will be the format
Yeah,
for there, ma'am?
that's what this has already been mentioned in the even in the live session. So you need not worry about the calculations. Intense calculations will not be there. So for quiz one, quiz and all, where you have that only the online calculator available with you. So whatever the calculations involved, that will be doable in that. Compared to the assignment where you had some more calculations involved, you will be using the physical calculator. No, so for exam purpose, what all calculations involved, that will be doable in that online.
Okay, ma'am.
So that you need not worry about in that aspect. Okay, so let us do some numericals first, and then maybe after 1 hour or so, we can discuss the mock paper. And you will get the solution PDF also. And if possible, I will try to share the revision PDF also, if possible. Okay. Are you able to see the screen, writing screen?
Yes, ma'am. It's easy.
Okay. So given the circuit, with respect to the terminals A and B, you need to find the Thevenin resistance and Thevenin voltage. And here in the circuit, you have a dependent source as well. So first, take some time and try to solve it on your own, and then we can discuss. So what do we do first? Maybe to find RPH, what we should do? To find RTH, Thevenin resistance.
De-energize the independent sources, and we may apply a test voltage across AMG and find out the current. Then the
Correct.
ratio will be the
Okay, so what about the dependent source in the circuit?
4 Vs is the dependent source, which depends on the voltage across that.
Yeah, that is fine. So as you say, when you try to de-energize the sources, what will you do with the dependent source?
We will
Ma'am,
keep it
keep it at
as it is in the circuit.
Okay, they will be intact in the circuit, correct? So we can't make them inactive as such. So this will be there is only one independent source, which is this 10-volt source. So that we replace it with short circuit to de-energize it. Then the remaining circuit will look like this: 2 ohm, 4 ohm, then the dependent source. So maybe I can here across the terminals A and B connect a test voltage source of value 1 volt, and let me consider the current coming out of that test source as I. So this is the test source, and accordingly RTH will be this V test by I test, so that will be 1 volt divided by I. Okay, so we have to first find out I. So if you apply KVL, what do you get? Minus Vs minus 9 Vs minus 1 equal to
Ma'am,
0.
why you added that 1 volt means?
We have the dependent, we have seen similar sort of questions to assignments also if you have gone through. So we have the dependent source and we are trying to connect a test source, and through that we are trying to calculate the Thevenin resistance. Either we connect the test voltage source or test current source. So here I have connected a test voltage source of value 1 volt. So that in terms of that, this RTH would be 1 volt divided by this current coming out of that test source I. And if you had gone through the assignment questions, we have solved similar questions with the test source, and even you have it in the, I mean, lecture where professors have taken one such example as well. That is in the case of dependent source when you have in the circuit. So Vs you will get it as minus 1 by 10. And in terms of Vs, you find out this I. Just check it out. I'm just writing the key equations. You just cross check with what you had done. Minus 9 by 2 Vs. So that I will be substituting this Vs as minus 1 by 10. I will be 9 by 20. So RTH will be 1 by.
Ma'am, how did you write that equation? Minus Vs minus 9 Vs.
Check it out. You apply KCL here and then apply KVL. You will get it. You just check it out here. This minus Vs, and what is the current flowing here? In this loop, you have to apply KVL. Here the current is 4 Vs.
Okay, ma'am.
So 4 Vs. Okay, so RTH will get as 20 by 9, and BTH will get as 10 volts. I'll just give you a few minutes. You can just apply KCL and KVL and just cross check these results. If you have any doubts in any of the steps, you let me know. I'll just tell you. First, being the mock paper and 1 day before the exam, try to do it on your own.
Hello, ma'am. Hello.
Yes.
Ma'am, I have one doubt. Here 4 represents the conductance, right?
Which one?
4 Vs. Here 4 represents the conductance.
4 Vs is actually the current. It is a
So 4
voltage
4 is
dependent.
the conductance.
It is a voltage dependent current source.
Yes, ma'am. So 4 represents the conductance.
Yes.
So 1 by 4 represents the resistance. So
Yes.
if without using, is there any possibility without using test source? So 4 plus 1 by 4 to get the resistance of that branch.
No, that may not be possible.
Okay.
Are you getting how I have written the first equation? Minus Vs minus 9 Vs minus 1 is 0. How did I get this? You consider this node. Okay. 4 Vs is the current entering this node, that is coming from here. And this current, what will be that?
I plus 4V.
This will be Vs by 2, correct? Correct?
Yes, ma'am. Yes, ma'am.
So Vs by 2 is entering this node from this side, and 4Vs is entering by here. So both are entering current. So Vs by 2 plus 4Vs will be the
2
current going through this 2 ohm in this direction, and I is opposite to that. And then I have written KVL in this outer loop. So minus 1, then the drop across 2 ohm, then this minus Vs equal to 0. Do you get the idea? I have just
Now
applied KVL in the outer loop. For that, we need to know the current flowing through this 2 ohm, and that current flowing through this 2 ohm is this Vs by 2 plus 4 Vs. And you have to be careful about the polarity, because Vs by 2 plus 4 Vs, if I add it up, that total current will be flowing towards right through 2 ohm. So the polarity would be like plus here, minus here, and I is coming in the opposite direction. So there you should not make mistake with respect to the polarity. Yeah, tell me. You were about to ask something?
Ma'am.
Are you getting it?
Yes, ma'am, I got. I wanted to ask one thing, ma'am.
Wait, let me just make it evident. So what I have done is applied KVL in this outer loop. 1 second. So the things I have shown here for your understanding, the current flowing through 2 ohm in the direction shown, I mean towards right, it is Vs by 2 plus 4 Vs. That is by applying KCL at this node N. So with that you will get Vs as minus 1 by 10, and then I will be minus 9 by 2 Vs, and with that you will get the RTH, and VTH also you can calculate. The open circuit voltage you will get it to be 10 volts. Yes, tell me.
Suppose there is a dependent source in the circuit and it is dependent on the voltage, current across node A and B. So, will there be actually zero Thevenin voltage, as we know that we short circuit it across A, B to find the Thevenin voltage?
I mean, you try to say that the dependent voltage source, it's a current source, and that current is through these terminals A and B.
Uh, there is a dependent source which is controlled by the current passing through A and B.
Okay. And then the value of that voltage, dependent voltage source, becomes 0. Correct.
Yes, ma'am.
You mean to say, once again, let me make that clear. You mean to say that the dependent source is current source, correct? And that current value is
Uh,
depending upon the current flowing through the terminals A and B.
Yeah, you can assume a dependent source to be a current source or a voltage source, but it depends on the current passing through A and B.
If it is the current source, dependent current source, and if that current is the current depending on the terminals A and B, then it becomes zero. That dependent source value becomes zero.
So Thevenin equivalence will be zero. Thevenin voltage.
That depends upon the topology, no topology of the circuit, where exactly the dependent source is connected. Then only we can tell. Correct. That depends on the topology of the circuit. Maybe one more with the dependent source. Let me take another example. And I think, if I remember correct, you had one question in the week 3 graded assignment, where a similar sort of question where you have a dependent source, and you will be calculating it using that VTH by that RTH is VTH by ISC. That means you have several cases with the dependent source. Okay, so sometimes you may have to calculate that short circuit current, then the Thevenin voltage, and the Thevenin ratio of the two will give you the Thevenin resistance. And one such example I think you had in graded assignment, if I remember correctly. Anyway, either in graded or practice, definitely one such question was there. So those were examples for you to get the understanding on this, calculating the Thevenin equivalent when there is a dependent source in the circuit. So here also I will take one another example where you have the dependent source. So 5 ampere current flowing through 10 ohm is Ix. It's shown here downwards, and dependent source is a current controlled voltage source. The polarity of the dependent source is shown. It is a current controlled voltage source. That current is depending on the value, the current flowing through this resistor 10 ohm, and you have a resistor over here, and you need to calculate the Thevenin voltage and Thevenin resistance with respect to the terminals A and B. So I will de-energize the current source by replacing it with open circuit, and the remaining circuit will be like this. So I will connect a test current source here. So I have marked the voltage across the test current source as V. So with this, what will be Ix?
1 ampere.
Yes, because you don't have connection over here, so Ix will be simply this current circulating in this loop. So with the test current source being 1 ampere, Ix will be 1 ampere. Then you apply KVL. What do you get? V minus 2 into 1 minus 3 into 1 minus 10 into 1 equal to 0. So this will be V equal to 15 volts. So RTH will be V by 1 ampere. So that will be 15 ohms. Then to find out the Thevenin voltage, so in this case, what will be the current flowing through 2 ohm? This will be VTH actually. So what will be the current flowing through 2 ohm?
4 amperes.
How do you get 4 amps?
From 0.
0. Because this side we are calculating the, Thevenin voltage is the open circuit voltage, correct? We are open circuiting this terminal, and then seeing from this terminal A and B, we are calculating the open circuit voltage. So this loop towards this side, it is open. So there will not be any current flowing through this 2 ohm. So the polarity, the voltage across this 2 ohm will be 0. So you will have only this loop in the circuit. So 5 ampere will be flowing through this 10 ohm and will cause a voltage drop of 50 volt across that resistance. So it will be VTH minus 0 volts, which is across that 2 ohm, then minus 3 Ix. You have a non-zero value for Ix, that Ix will be 5 amps in this case. Okay, so 3x will be active, that dependent source, minus 3x minus 50 equal to 0, because 5 ampere, as I told you, it will be flowing through this 10 ohm and will cause a voltage drop of 50 volt with polarity like this, and here it will be 0 volts across this 2 ohm resistance. Okay, so you will get it as 65 volts. Clear?
Yes, ma'am.
Can you just try this out and let me know the values for I and R? The given circuit is equivalent to a current source of value I in parallel with a resistance R across the same terminals A and B. So you have to reduce the given circuit in this form with a simple current source, in parallel to a resistance R. So what will be the value of that I and R which you need to calculate?
Minus 1.5 amp and 8 ohm.
Wait, let me just check it out. What is the value of I and R? I is?
I is minus 1.5 amp and R is 8 ohm.
Yeah, I is minus 1.5 amps and R is 8 ohm. Yeah, right. So you need to take care here. At least some of you, definitely these sort of mistakes we had seen in your seniors. Even though you would have done it right in your paper. Finally, when you enter the value for I, you would be entering it as 1.5. So with the shown direction upwards, but the actual value is downwards, I should be entered as minus 1.5, not 1.5 simply. So towards this side, that voltage source of 20 volt in series with 40 ohm, I can source transform that. So that will be a current source V by R, so zero 0.5 ampere. And with the given polarity of voltage of 20 volts, the current direction should be upwards and value will be 0.5 amps. That we get it by 20 by 40. So that in parallel with 40 ohm. Then you have here another current source in parallel with the resistance. So 2 ampere is, if you consider this as the node N, then 2 ampere is leaving the node and zero 0.5 amps is entering the node. So in effect 1.5 amps is leaving the node N, and this would be 40 parallel 10. So I, it would be minus 1.5 amps, and R, it is 8 ohms. So this is just a simple question on source transformation. So what should be the value of the load resistance RL such that maximum power is delivered to it, and you need to calculate how much is that maximum power as well.
It is 2 ohm. RL will be 2 ohm.
RL is how much?
2 ohm.
2 ohm, ma'am.
Yes. And power is, maximum power is?
I think 4 watts, ma'am.
How much?
4 watts.
No. It's not 4 watts.
Two watts, ma'am.
No, it's not 2 watts. It's not 4 watts. Both are wrong. Check it out once again.
Ma'am, 6 watt.
How much?
6.
No. What is the terminal voltage?
Two volts, ma'am.
No. Okay, let me just show you.
Three volt Thevenin voltage.
How much? 3 volts.
Yes, ma'am.
Yeah, 3 volts is the right answer for the Thevenin voltage. So with that, what will be the maximum power?
4.5.
4 point. No. If you have done the values, I mean for the Thevenin voltage and the Thevenin resistance, right? Then you're not
Sorry,
supposed to
sorry, I did a
have this
mistake.
power. Yeah. Sorry.
Ma'am, 1.125 watts.
Yes, correct. So this 1 ampere is flowing through this, so that will cause a voltage drop across this 2 ohm resistor as 2 volts. Here also 2 volts. So here it would be 0.5 amps and 0.5 amps. So that would be 1 volts here. Anyway, that we know, correct? So DTH it would be 3 volts. And for RTH, I am suppressing this 1 volt, then 2 ohm, 2 ohm, and 2 ohm. I'll open circuit this current source as well for suppressing that. So this will be RTH. So RTH will be 2 ohm. So for maximum power transfer, RL should be equal to RTH. So that should be equal to 2 ohm. And maximum power, you will get it as 9 by 8, which is 1.125 watts.
Hello, ma'am.
Yeah, tell me.
Ma'am, here 9 is V square. That is Thevenin voltage. Okay.
Okay.
And 8 is the resistance for what?
Which one? Once again, can you tell me?
Ma'am, here 9 is V square. That is Thevenin voltage.
It is 4 VTH square by R. So how you will be getting like this, correct? I'm show you. VTH VTH RTH. Then you will connect the load RL. So for maximum power, RL will be equal to RTH. So uh, maximum power will be I square RL, correct? And that I will be VTH by 2 RTH. So it will be simply power will be this VTH square by 4 RTH, because you will get RTH square here into this RL, which is RTH. So simply it will be this 9 by 8. Okay.
Ma'am, here RL and RTH are in the series combination.
Yes.
Then RTH will be 2 and RL will be also 2. Then the equivalent will be 4.
Correct.
Mm, okay.
See, once you find out the VTH and RTH, then you connect VTH in series with RTH, and then you connect the load. That's what here I have shown, VTH in series with RTH, and I have connected load, and this is my terminal A and B across which the load is connected. And for maximum power transfer, we know that the load resistance should be equal to the Thevenin resistance. So Thevenin resistance, we have just found out. We have suppressed the two independent sources. One was current source, and which was suppressed by replacing by open circuit. And here 1 volt was suppressed by short circuit. And with that, we find that RTH is 2 ohm. So with that, for maximum power transfer, this RL should also be 2 ohm. So the current flowing in the circuit will now be I will be VTH by RTH plus RTH. RL also being RTH, it will be RTH plus RTH. So I will be VTH by 2 RTH. And maximum power will be I square R. So that I is VTH by 2 RTH. So VTH square by 4 RTH square into RL, which is also RTH. So RTH square, RTH will come in the denominator. So 4 VTH square by 4 RTH will give you the value. So VTH square is 9 volts. RTH is 2, so it will be 9 by 8. Okay.
Ma'am, can we do V square upon R? And V square will be 9 and divided by R will be 4.
Yes, you are taking like VTH square by RL. That is wrong.
VTH squared upon RL plus RTH.
VTH square upon RL
RL plus
plus
RTH.
RTH. How do you get that we have RL plus RTH? It should be VTH square by 4 RTH. And how I have shown here, it is I square RL. It should that I should be the load current. What is that load current I in terms of VTH and RTH? It will be VTH by 2 RTH. So when you
Yes.
square that, it will be VTH square by 4 RTH square. Then into this RL, which is RTH, you will have VTH square by 4 RTH. How do you get it as VTH square by RL plus RTH? That is wrong.
Okay, ma'am.
So this was question number 4. Try to do this and let me know the values for the Thevenin voltage and Thevenin resistance.
Ma'am, RTH will be 3 ohm, 4 ohm,
RTH is how much?
4 ohm.
1 second. No? RTH is
No,
not.
ma'am. No, ma'am.
Ma'am, RTH will be 1 ohm.
Yeah, RTH 1 ohm, Pratibha, you are right. And VTH?
We have confusion in calculating the BTS.
Okay, let me know.
Ma'am, VTH is 3 volts.
Correct. VTH is 3 volts and RTH is 1 ohm. So for those who didn't get, I will just show you here right now. Uh, so let me consider this as node N. Then nodal voltage is V. Then V by 2 minus 3 Vx minus 3 equal to 0. This is KCL at N. V by, I'm considering this nodal voltage as V. So towards this side it will be V by 2, which is the leaving current, and the entering current are 3Vx and this 3. So 3Vx plus 3 will be equal to V by 2. And Vx will be equal to V by 2 into 1. So that will be V by 2. So that is the relation connecting Vx and V. So with that, you will get the value for V as minus 3 volts. Then if you apply KVL here, minus VTH plus 6 minus 3 equal to 0. So VTH equal to 3 volts. So minus VTH, so 3 plus 6, then this will be actually V. So that is minus 3 volts. So KVL here. Okay, and to find out RTH, so I will let me short circuit the terminals to find out the short circuit current. So if this is P, so here also let me mark better it as V so that you will not get confused. Okay. So V by 2, that is this leaving current towards this side. So minus 3 Vx, then plus V by 2 equal to 0. So V by 2 is this one, okay, and this V by 2 is this, because here it is a short circuit, so the current will flow like this, and 3 Vx is entering, the other two are leaving. So V by 2 minus 3 Vx plus V by 2 will be equal to 0, and Vx will be equal to V by 2. So you will get it as V as 0. So ISC will be 3, and RTH will be VTH by ISC, that will be 1 ohm.
Ma'am, could you explain once again from second part VTH?
Wait a minute please. Yeah, tell me.
Ma'am, could you please explain once again from from
Which
above
one? Which
VX?
question? This one, V by 2.
Above. No, ma'am. Just above. Just above.
This one.
No, ma'am. No, ma'am.
Above. I mean to find VTH.
From Vx, yes ma'am, Vx equal to V by 2 into 1. How? I didn't understand this point. Vx
If
equal
you
to
get
V by
these
2
two
into 1.
equations, first of all, are you okay with the KCL? This KCL equation, V by 2 minus 3 Vx minus 3, that is fine for you?
Yes ma'am.
Okay, then are you
How
getting
to
Vx
minus
plus
3
V
one?
by 2?
Yes ma'am.
And then if you are getting these two, then what is the problem? You just need to substitute for Vx here, V by 2, and solve for V, right? You will get it as minus 3 volts. In this equation, the KCL equation, once you have got the relation connecting Vx and V, and you are telling that it is okay for you with the KCL equation and Vx is V by 2. So substitute Vx as V by 2 in this equation. So V by 2 minus 3 V by 2 minus 3, you will get V as minus 3. Correct?
Okay.
So you get as V as minus 3. You just substitute here. Maybe this as equation 1 and this as equation 2. Substituting 2 in 1. What do you get substituting 2 in 1? V by 2 minus 3 into V by 2 minus 3 equal to 0. So you will get it as V minus 3
Yes
V
ma'am, I understand.
6 equal to 0, V equal to minus 3.
Yes ma'am.
And are you okay with RTH?
Yes ma'am.
Others also? So RTH is 1 ohm and
Yes.
VTH is 3 volts. So this was question number 5. Okay. So maybe a few more questions we can do and then we can go through a fast glance through the mock paper. Okay. So 6th question. Tomorrow you have exam in the afternoon, right?
Yes ma'am.
Okay.
Yes, ma'am.
Find the Norton equivalent with respect to the terminals A and B.
Ma'am, just 1 second. Let me draw.
Wait.
Okay, ma'am, I've drawn. Wait a minute.
So if you have doubts in any of the steps, you let me know. So for VTH, I have shown here the respective loops, the loop currents also. So KVL in this first loop, you will get it as minus 2 VA. Here, the mesh current, I have taken it as I1 in the clockwise direction. Here it is I2. So the current flowing through this 2 ohm, it will be 2 into I1 minus I2. Then here it will be 2I1, because this side we have open circuited. So only the current I1 flows through this 2 ohm. There will not be any current in this loop. Okay. Then so that will give you this first equation. Then when you apply KVL here in this loop, that will be 1 into I2. So I2, then plus this 1 volt. Then here it will be plus 2 I2. Again, since there is no current in this loop, only I2 flows through this resistor. So that will give you 2 I2. Then here it will be 2 into I2 minus I1. Then plus 2VA equal to 0. So that will be the KVL in this loop, which gives you the second equation. Then if we try to find out the expression for VA, it will be the voltage across this 2 ohm, and the current flowing through this 2 ohm, it will be I1. So 2I1 will be VA. So you can substitute this VA as 2I1, and that will give you, when you substitute for VA as 2I1 in these two equations and solve for I1 and I2, you will get I1 as 2 and I2 as minus 1. And then I have applied KVL here in this loop. So here it was 2I2, here it was 2I1, and then VTH. So substituting for that I1 and I2, and then writing the KVL, we will get VTH as 2 volts. So finding the VTH value, is it clear? Anywhere if you have any doubts?
Yes, ma'am.
And then coming to finding RTH, again I have shown the respective mesh currents, I1, here I2, I3. So again you write the KVL. So minus 2 VA plus 2 into I1 minus I3 is the voltage drop across this 2 ohm. Then here it will be 2 into I1 minus I2 equal to 0. So that will complete the KVL in this loop. Okay. Then maybe here also again I can mark it for you. This is 1. This is 1. Then this is 2. And this is 3. Okay, I have written the respective KVL equations, and here also try to write the expression for VA. It will be 2 into I1 minus I2. Then you substitute for I1 and I2 and solve it. You will get I2 as 2, and I2 is same as that short circuit current, the Norton current. And with, in terms of VTH and ISC, the Norton resistance will be VTH by ISC, which will give you 1 ohms. Okay, so maybe I think we are done problems on week 3. Maybe few 2-3 questions on week 2 and week 1. Then maybe last 20 minutes or so we can just go through the mock paper. Okay, so I will just take some questions from the other 2 weeks. So a series circuit consisting of two pure elements has the following voltage and current expressions. V is given by 15 cos 200 t minus 30 degrees and current is 8.5 cos 200 t plus 15 degrees. We need to calculate the elements comprising the circuit. So what is the phase angle between the voltage and current? What is the phase angle between voltage and current from the given expressions?
15 degrees.
How much?
15 degrees.
15
December.
degrees. Is it 50 degrees?
45, ma'am.
Yeah,
15 to
45.
45, ma'am.
It should be 45. Here you have the reference 0 degree line. So 1 is minus 30. Minus 30 means we take it in the measure it in the clockwise direction. So minus 30 will come somewhere here, and plus 15 will come somewhere here. Okay, so between the voltage and current, it would be 30 plus 15, 45.
Yeah, okay, ma'am.
Now is it clear?
Yes, ma'am.
Okay, so the theta, which is the phase angle between the voltage and current, that will be, that is actually here 45 degrees. So tan theta will be, so here which is leading, voltage or current?
Current is leading.
Current is leading, correct? So current expression is you have here plus 15. So current is leading the voltage. I leads V. So what do you expect the elements in the circuit? It will be R and
RC.
C. And you need to find the value of R and C. That is the question. So if you have identified that to be the series RC circuit, what will be tan theta? It will be 1 by omega CR, correct? So tan 45 will be 1 by omega CR, and you know tan 45 is 1. So 1 by omega C, it will be equal to R. And impedance, if you see, it will be square root of R square plus XC square. So that will be square root of R square plus 1 by omega C the whole square, and 1 by omega C being equal to R, that will be square root of R square plus R square. So that will be root 2 times R. So here from the given expression, what is the value of Z? It will be Vm by Im. So that will be how much? 15 by
15 by root 2.
15 by 5. So 1.764 or something. So R will be set by root 2. So you will get it as some 1.248 ohms. And omega, how much is omega? the value of omega? See
200.
yeah,
200.
200. Because here you can see in the given expression, correct? 200t, 200t. Okay. So omega is 200, from which you can calculate C. Because you know 1 by omega C is equal to R, and we have calculated the value of R. So it will be 1 by 200 into this R value, 1.248. So you will get it as 4 millifarad. So it will be a series circuit of resistance R as 1.248 ohms and capacitance 4 millifarad. Shall I move on to the next question?
Ma'am, can we do a mock question? I have a doubt there.
Yeah, I told you. Just wait a few more minutes, 2 more questions, and then we can just go through that. Don't worry, you will get the PDF for that as well after the session,
ma'am.
and I will share with this also, this PDF also. So I just want to complete the questions on the first 2 weeks as well. So 2 more questions. A similar question, maybe I will just give you the question and the answer. You can cross check once doing that. A resistor R of 10 ohm and an unknown capacitance are in series. Voltage across the resistor is VR equal to T sine 1000 T plus 45-degree volts. If the current leads the applied voltage by 60 degrees, find the unknown capacitance. So here directly we know that it is RC circuit, and it is given that the current leads the voltage by 60 degrees. So tan 60 will be 1 by omega CR, and R is given to be 10 ohms. Omega is 1000 radians. So substituting, you will get C equal to 57.7 microfarad. You can just cross check later.
Ma'am,
Yeah.
ma'am, could you please show the question again? Question 8.
Previous question.
Yes, ma'am. Okay, ma'am.
So, given the circuit, an impedance is connected across a voltage source and the current flowing in the circuit is I. You need to determine the impedance set when a voltage of 30 plus J50 volt is applied and the current flowing is minus 5 plus J15. We are also asked to calculate the phase angle. So, impedance set will be Vs by I. So, that will be 30 plus J50 by minus 5 plus J15. So for this purpose, I mean, if it is was for assignment, you can make use of the complex mode and directly do the division between the rectangular forms, or manually you can convert this into polar, this also into polar. How do you do it manually? We had discussed in the respective live session. So this will be a plus jb form. So square root of a square plus b square will give you the magnitude part of that polar form, and tan inverse this 50 by 30 will give you the angle. So accordingly, you will get it as 58.31 angle 59 degrees divided by 15.81 angle 108.43. So that will give you 3.69 angle minus 49.43. So this 3.69 angle minus 49.43, that will be in rectangular form equal to 2.4 minus j 2.8. That means a resistance of 2.4 ohms in series with a capacitor with Xc equal to 2.8 ohms. The capacitive reactance, because this is R minus JXc. You know that for RC circuit it is R minus JXc. So this is R, this is Xc. The real part is the resistance value, imaginary part is the capacitive reactance value. So Xc will be 2.8 and R will be 2.4. So the impedance will be actually a resistor in series with a capacitance, and the resistor value is 2.4 ohms and the capacitive reactance is 2.8 ohms. Not the capacitor value but the capacitive reactance. And one last question. mean the equivalent impedance. So here you have a 5 ohm in series with an inductive reactance of value J10 ohm. Similarly, here you have, so this is a composite circuit. So if we can try to make it something like this, Z1, where it is the series combination of 5 and J10. Okay, this I am taking it as a whole, this series combination as one impedance Z1. Then here Z2 I can take it as 2 minus J4 ohms. So that is here 2 minus J4, and in a similar way set 3, what will it be? It will be 1 plus J3 ohms, 1 ohm in series with J3. Then the total impedance will be Z1 in series with Z2 parallel to Z3. So that will be Z1 plus Z2 Z3 by Z2 plus Z3. So you can substitute the values, do the interconversion between rectangular and polar, and finally you will get the value as in rectangular form 9 plus J 11.96, or in polar form it will be 14.96 angle 53.03. So that means it will be effectively a circuit containing 9 ohm in series, the real part 9 ohm in series with an inductive reactance, because this is plus, so this is an inductive reactance of value 11.96. Okay. Now tell me what which question you have doubt from the mock paper.
Ma'am, question number 13.
Can you just read the question?
For the circuits shown below, the
Okay.
power consumed by the 5 ohm resistor is 10 watt. The power factor of the circuit is.
Okay. I will just share it.
Ma'am,
Yes.
ma'am, in week 1 graded assignment, question number 14. Ma'am, the answer for that question is not given in the solutions, ma'am.
Wait a minute, Prithvi. I will just go through that mock paper and let you know.
Okay, ma'am.
Can you see the screen here? Question 13.
Yes, ma'am.
So IRM power is given to be 10 watts. So IRMS square into R is 10 watts. So R is 5 ohm. So IRMS square into 5. So with that we get IRMS as root 2, because IRMS square is 2. So IRMS will
Ma'am,
be root 2. Yeah.
Here, it is written 5 angle 0 for the voltage source. But how do we know that it is in IRMS or it is Vmax 50? Sorry, not 550.
For finding the power factor, you need not worry about RMS or peak, no?
No, no. In general, I am asking.
In general, what is your question?
In general, whenever it is written, suppose we have a voltage source and the value of it is written like suppose 50 angle 0. So here, what is
Yeah, see,
50? Is
yeah,
it
yeah, yeah, yeah. Wait a minute. As you say, in general, if it is given in some polar form, unless otherwise specified, we don't know whether it is peak or RMS. So it should be explicitly mentioned whether it is peak or RMS. And if suppose it is not mentioned, you are supposed to take it in convention RMS. Okay.
okay?
Either it would be, if it is considered it to be as peak, it would be explicitly mentioned. If not mentioned and it is in some polar form, as you say, by convention, you consider that magnitude part of that polar form as the RMS value itself. And if it is given in the time domain expression like phi sine omega t, that you know that that phi is actually the peak value because it is Vm sine omega. That expression, time domain expression, you would have learned in the ESTC paper, correct? So if it is in the time domain expression, there
Yes,
is no
ma'am. That's
confusion.
clear.
That is peak. But as you say, polar form, it should be mentioned whether it is peak or RMS. And if it is not mentioned, better you consider it as RMS by convention. And here finding the power factor, I'm just showing you, is the things clear? Cos phi, it will be the voltage drop across the resistor R by the total voltage VR by VT. So you will get it as 15 root 2 by 50 by root 2 because we are considering the RMS value. So that will be this one and you will get it as 0.6. Okay. So 15 into root 2 is actually 15 is the resistance value and the voltage across that resistance will be the current we have calculated IRMS as root 2. So 15 into root 2 will be the voltage. So that will be VR and total voltage, the RMS value will be 50 by root 2. So VR by VT will give you power factor. So 15 root 2 by 50 by root 2, that will give you 0.6.
Ma'am, 50 divided by root 2 is the VRMS, ma'am.
50 by root 2 is the RMS value of the applied voltage. This one. VT, the total voltage, applied voltage. And VR is the voltage across the resistor. And resistance value we know, IRMS we have calculated to be root 2. So I into R, 15 root 2 will be the voltage across the resistance. And the ratio of those two voltages, the voltage across resistor to the voltage of total voltage will give you the power factor. So you will get as 0.6.
Ma'am, I tried finding the answers using different method using first finding the impedance that is that reactive part and then dividing
How can you
the
find the impedance? You don't know the L value, right?
I first found I because it's given for the that 5 ohm resistor that power dissipated is 10 watt. So we can use I square by magnitude of Z.
That is what we have calculated here. You will get I to be root 2, correct?
Yes, ma'am.
Okay,
Root 2
and then
ampere. Then what I have done? I wrote I equals to magnitude of a voltage which is 50 by root 2 and divided it by the magnitude of impedance which is 15 root under 15 whole square plus XL whole square. XL is unknown.
okay,
Then XL turns out to be 2275 sorry, XL square turns out to be 2275. And when we do the calculation,
Then you have calculated
we
like
got
tan theta is XL by R, correct?
no, not like that. We calculated the magnitude of the impedance, which is equal to root under 15 square plus XL square.
Okay.
And we know that when we divide
The angle involved in the
voltage,
impedance, you have considered it to be theta, and you have to take the cos of that, correct?
yes, ma'am. And what I got was 15 divided by 50, which is 0.3. I repeatedly gets it. So can we do that way, ma'am? One time, as it will be clear.
As far as what I have listened to you right now, the procedure is fine, but maybe you have gone wrong somewhere numerically. You say that you have calculated the magnitude of the impedance and the angle involved in the impedance, the cos of that angle you have taken for power factor, correct?
Yes, ma'am.
So procedure is right, but you just check where you have gone wrong numerically. Answer, it should be 0.6 for the power factor, cos of the angle that you get. So maybe somewhere numerically you would have gone wrong. Procedure is fine.
Ma'am, I have done this actually 2 or 3 times, and results are same. That's why I thought.
Can you just take the snapshot and share it with me in the discourse? I will just reply after the session. Not immediately after the session, sometime this night I can do. Take the snapshot of what you had done and then share it with me in the discourse so that I will just go through that and reply to you.
Okay. Tomorrow, but my exam is.
Yeah. This night you can do. I will just see to that and reply. Tomorrow afternoon only you
Okay,
have the
okay.
exam, right? If you can post it immediately, tonight I can respond to you seeing your snapshot. You just take a
Okay,
snapshot
okay.
of
I will
what
do
you
it.
have done. You right now what you tell you have done 2-3 times. That solution you take the snapshot and share it in the discourse so that I will see to that
Okay,
and
ma'am.
reply.
I will do it freshly and share it with you. And maybe if I have done any mistake, then
Yeah. You can
I will
just
get
share
to
it
know.
with me. I will just see and then reply to
Yes,
you.
ma'am.
So any other question for others? I mean, this PDF anyway we will share it with you. You will get it this night. This mock solution, and if you require today's PDF also, I will share it with you. This revision PDF. So other than that, any particular question you find it difficult, or if you want any doubts to be clarified from the mock paper, you may ask, or else you can just go through the mock solution once it gets released. Any particular question? I don't think it was moderate paper, and there was not much difficulty involved. I hope so. For those who had prepared well, you would be able to do that. And even the exam tomorrow, it would be in a similar way. But see that you have sufficient practice with the numericals. If those who are simply going through the solutions for the assignments once it is getting released and not have done on your own, will find it difficult. So there should be sufficient practice from your side. So any other question from the mock paper?
Ma'am, question number 20.
Question number
20.
20. Okay.
12,
12 or 20?
12, ma'am.
12,
Sorry,
12.
12.
Okay. Yeah, here I have shown. So it is asking for that capacitance value, right? So with the power and this voltage given, you can calculate the current. Okay. Then by vector concept, you know that the voltage across the capacitor, it will be square root of the applied voltage, total voltage minus this one, the voltage across the resistor, because In other words, the applied voltage V, it would be square root of Vc square plus Vr square. So from that you can calculate the capacitor voltage like this. So you know the applied voltage and this one Vr. So with that you can calculate the magnitude of the capacitive voltage, which is this 201.99.
Ma'am,
So
actually,
capacitive, okay.
I didn't quite get the question. That's why I was making so much mistakes there. Can you explain the question?
You didn't understand the question.
I have a doubt there that capacitance is kind of later in the second part, or it is there in the both circuit when we connect it to 110 volt.
No.
Uh,
The question is
uh,
the same brightness in both the circuits. Correct?
Yes, ma'am, but the capacitance is there in both the scenarios. Or we connect it later and we are asked to find the value of that. What is it?
It's not there.
Capacity.
It's not there in both the circuits. We are comparing the two circuits, and we say that it's the same brightness. Capacitor is there in only one of the circuit.
So we treat a lamp as a resistor only, and we connect it to a 110 volt supply, and then we extract 100 watts from that, and then when we connect it to 230 volts 50 hertz supply in series with capacitor, we are asked that the power it consumes should be equal, that is 100 watt. So what will be the value of the capacitance? Am I right, ma'am?
Yes.
Okay.
And Prithvi, for its you graded question 14, correct? Week 1. Prithvi
Yes,
is
ma'am.
here.
Yes, ma'am.
Can you just read out the question?
Yes, ma'am. When a voltage V of t is equal to 100 sine 5000 t volts is applied to a series circuit of two components. Inductor L is equal to 0.05 Henry and unknown capacitance. The resulting current is I of t is equal to 2 sine 5000 t plus 90 degree amperes. The value of unknown capacitance is.
Yeah, this is similar to what we had done sometime before, right? You have given the voltage and current expression. So with that, you will get the, the phase difference between the voltage and current from the given expressions. That means the theta value. Then tan theta, being the RC circuit, tan theta will be 1 by omega CR. Or here what it is, inductor or capacitor? The question.
It's both, ma'am.
Resistor and inductor, RL circuit, correct?
No, ma'am. It's an LC circuit, ma'am. They have both inductor and a capacitor in
In a
series.
similar way, you can do correct here. Some the question that we had done before. In a similar way, it is an LC circuit. You can find out from the given expression V and I. You just post it. I will just see that question. It is, but anyway, just similar to what we had done sometime before.
Okay,
Question 14 of graded week 1, correct?
Yes, ma'am.
Yeah, put it in the discourse, but I don't know whether it was not there in the solution release. But anyway, I will check. But the same procedure as what you know. You find out the phase difference between the thing and then relate it with the reactance.
Okay, ma'am.
Okay, so tomorrow, please see that you have sufficient practice with the question so that you don't spend much time in a single question. And also see always, don't make mistake with the polarity. Like one particular question today we had in that source transformation where the current was showing upward. So it should be entered like minus 1.5, something like that. Because we have seen a lot of similar mistakes in the past term. you would be doing the things right, but ultimately entering it wrong, you lose your marks. So I just request you not to commit such mistakes and lose your marks. So prepare well. All the best, and we will be seeing again on Monday. So mock solution I will release. Do you want this PDF, or is it fine that the discussion that we had today, is it fine? The YouTube link, today's session. Is it fine? Or you want the PDF? I'm asking for today this revision session PDF. Do you want?
It's fine, ma'am.
Please share the PDF.
Okay, fine. Okay, so I will just ask the just follow up with the ops team that they are sharing with you the solutions. So either mostly tonight or early morning tomorrow. Mostly tonight, I will just make sure that it is getting released. Okay. So we can see again on Monday. All the best. Thank you.
Thank you, ma'am.
Yeah, thank you everyone.